Okay, so in this video, we will find the equation of a hyperplane when we have 2 points on that plane and a vector. Okay, uh, let's draw a figure to understand it better. So say this is my three-dimensional plane. Also, these can be in any number of variables, but because we can represent three dimensions, a maximum of 3 dimensions, because it is easier to represent and easier for us to visualize. That's why I'm using all the examples in this dimension, 3 dimension. Okay, but it can be 4, 5, 6, 10, 20, whatever. But that can't be represented with geometry. That is more of a data science thing, which I'm learning. Okay, anyway, back to this. So say this is our plane, right? Yeah, looks like a plane. And now what we have been given is a vector. Okay, let's say we have a vector u, which can be a1, a2, a3, and so on till an. Okay, and then we have 2 points on this plane. Okay, say we have this point and this point. This is p and this is q. Now point p will be, I'm talking about the general case. Point p will be something like x1, x2, so on till xn, and point q will be okay x dash 1, x dash 2, so on till x dash n. Okay, just to differentiate, these are 2 points lying on the plane, and then we have a vector u. Okay, now this vector can either be perpendicular to the plane or, okay, first let us discuss the case when it is perpendicular. Actually, we have already discussed that. Suppose this is our vector. Okay, that is not a good. Suppose this is our vector, right? And this is perpendicular to the plane. So again, like in our previous video, we have a vector perpendicular to the surface, and we have a point. Actually, we have two. We can use any and use the same method to find the equation. Okay. Now the second case, when we have been given a vector, could be that this is not, what if this vector is actually parallel, this vector is, what if this is the vector u? So this actually turns out to be parallel to the vector joining p and q, right? So either we will have a vector that is perpendicular to the surface, or we will have 2 points. We will have a vector joining the points, and we will have another vector u given to us, which will be perpendicular to the line joining p and q, right? Now what happens in this case? So let's see what happens in this case. Let's take our points to be, let's take p equal to 2 minus 3, 2, and let's take q equal to, it looks like x is negative, minus 3, 2, and 2. Okay, right. And let's say our vector u is, vector u, let's take it anything, 2, 1, 2. Okay, let's say this is a vector, right? or 242. Let's take 242. So now what do we do? Now this becomes a little tricky because all we know is that a point and a vector perpendicular to the plane. That's how we write, that's how we express the equation of the hyperplane. In this case, a two-dimensional plane in a three-dimensional setup, obviously. So, because these are basically the two same vectors. If PQ and U are parallel, then they are basically the same vectors. Just a scalar multiple, one is the scalar multiple of another. So it won't solve any purpose. They are just giving same vector twice. Exactly. I'll leave it be. So what we need is another random vector on this plane, U. Okay, my bad. Another random vector on this plane, say this is our vector. Okay, U, right? Yeah, this makes sense. So I'll let this be U. This is our U, and this is not parallel to the line joining P and Q. This is just a random vector on the plane. Now we need a point and an orthogonal vector to the plane. So we will find the orthogonal vector. See, we know about cross product, right? So cross product is if I have two vectors, then cross product gives me a third vector that is perpendicular to these two vectors, right? So this is what we will do. We will take this as P, this as Q, or you can take QP, does not matter. So this will be our first vector, and then this vector U will be our second vector. And from here, we can find our third vector in upward direction. So I'll have to, yeah, take a guess. How do we find a vector orthogonal to two given vectors? Well, we find their cross product, right? So I'll find U cross PQ, and that will be this vector right here. And if this is perpendicular to my vectors, these vectors, it will also be perpendicular to the plane, right? So that is how I will find my orthogonal vector, and then I'll find the equation of the plane, right? So let's do that. Let's do that. And something just hit me. What if we have a five-dimensional plane? How are we going to find the cross product of those vectors? As of now, I am not sure how. If it can be done, then I'll upload a video regarding that. But if it can't be done, then I think they will give like vectors. As I said, this geometry is just limited to three dimensions. Beyond that, it is data science, solving equations, storing data, dealing with data. So we can forget about these representations. Okay. Anyway, let's solve this. Now our PQ vector will be, okay, our PQ vector will be Q minus 3 minus 2, then 2 minus 3, and 2 minus 2. Okay, let me make a little change here. I'll instead of this 2, let's take 4. So now I'll have 2 minus 4. Okay, even that can be the case, but just for a better explanation, let's not make it 0. So this becomes negative 5, positive 5, negative 2. So this is our vector PQ, and this is our vector U. Now U cross PQ, we find the determinant. Okay, I write the components of U, 2, 4, 2, and negative 5, 5, negative 2. So this vector comes out to be I gap minus 8. I hope you already know this. Of course you would. What am I thinking? But still, my I component, I will leave these. Then I will multiply this, which is minus 8. And then I'll subtract the product of this 5 into 2, which is 10. Okay. Then next what I'll do is for my j component, now this is the odd position, like this is 1 by 1, a 1 1, 1 plus 1 is 2. This is an even position. This is a1 2, 1 plus 2, like element, the position a1 2, that is odd. I hope you already know this. Okay, so this will be negative j cap. Now what I'll do is I will oh, I'll skip these and I'll repeat the same procedure. Product of these two, which is negative 4, okay, minus product of these two, which is again negative 10. Negative 10. Okay. And my k component will be the same procedure. I hope I okay. For the sake of clarity, I'll repeat it. What I'll do is I'll forget that they exist. Product of this, which is 10, minus product of these, which is negative 20. Okay, wait, yeah, okay, so this is our cross product, and let me squeeze it in here. Our orthogonal vector, let's name it u, sorry, not u, let's name it v. Okay, so this v vector, v will be minus 18. This will be negative 4, positive 10, positive 6, and then negative 6, right? Yeah, right. And this will be 30. Okay, pretty large vector. So this is our vector perpendicular to the surface. And now I'll write the point here. Any point. You can take any one of these, this or this. Let's take Q, okay? So my point Q, I'm writing it here. It is negative 3, 2, and 2, right? So this is my point. And now I will find the equation, which is a1x1, in this case x, because a1x plus a2y plus a3z equals b. Okay. Now a1, a2, and a3 are supposed to be the components of the orthogonal vector. So I'll plug in 18 minus 6 and 30 here, and xyz are the coordinates of these points. These. So I'll plug it here. Negative 3, 2, and 2. And this will give me the value of b, which is 18 threes, 54, minus 12 plus 60. So this is 6 and 5, 114, minus 12, which is 102. So my required equation of the hyperplane with the help of 2 points and a random vector on that same plane, not orthogonal to it, but on the same plane, that equation turns out to be, okay, let me write it in black. Yeah, we have already reached 18x minus 6y plus 30z equals 102. Okay, so this is my equation. right? And obviously, I can factor out whatever I want. So I'll factor out 6 minus 6x minus y plus 5z equals 17. So this is my equation, right? Yeah. I hope this helps. If you have any confusion, just ask me in the comments.